students, welcome to the video lecture series of data structure. Our today's topic is priority queue and application of queue. Hi, this is your instructor Janice Shah. So let's begin to understand the concept about the priority queue. Students, this is all about the priority queue. Have you ever tried to do a payment, an online payment? Okay, so just imagine a situation that in your computer you are just playing a music in Windows Media Player or the PLC Media Player. And the simultaneously you are running your programming code doing the Java or NetBeans or anything else. At the same time, students, you are going to perform to click on the browser and doing some online payment activity. So what happens? Your CPU has three different operations. The CPU has three different processes in a queue. One is window media player, one is the NetBeans or Java coding, and third one is a online payment gateway processing. So at the time, your CPU should give the higher priority to be executed to its memory and all the processing power to the highest priority process. This is all about the priority queue. So priority student, priority queue works same as our normal human priorities queue. If you have a higher priority, you will be the first one to be executed in a queue. If you have the higher result, you will be the first one to get the seat in your particular choice of the exam. Okay, so this is how the priority queue works, students. Priority queue is nothing but a special type of queue in which each and every element associated with a priority. Okay, if your priority is higher, the insertion and operation or deletion operation performed on you the first time. Here are the students the types of the priority queue. Here we have the two different types of priority queue. One is ascending order priority queue. Second is a descending order priority queue. That means ascending order priority queue, that means low to high. The queue which has the lowest value, it gets the highest priority. In descending order priority queue, the queue which has the highest value get the highest priority. Fine. So this is how the priority queue works. See, the representation of the priority queue, students, here we have a two-dimensional array to represent the priority queue. So students, here if you can see the table, here I am representing my priority queue in a two-dimensional table. The first 10, 10 is my first queue, second queue is 2, 5, 10, third queue is 52 and 85, and the fourth queue is 99. I am going to represent the priority queue in the form of matrix over here, two-dimensional array in the below of the table. I just going to represent the value of the front and rear. So if you can see the queue with the 0 priority, it has the front and rear at 0 and 1. See, in the first 10, 10 queue, front position is 0, rear position is at 1. In the second number queue, the front position is at 2, that means 0, and here is pointing at 10, that means at second position. So front is at 0, rear is at second. So that's why I have written like this in the second row of the below matrix, that the one is front is at 0 and rear is at 2. If I'm talking about the third queue, okay, 5285, I'm talking about the third queue 5285. So the front pointer is at 1 and rear pointer is at 2. That's why I've written over there 1 and 2. And at last, if I'm talking about the 99, a front pointer and rear both are at the same position, that is 3. So I have written like this, front and rear at 3. Such like this, you can do the 2D representation of priority queue. The single dimensional array can use to keep the track of front and rear position of each queue. Here are some applications of queue, students. When the resource is shared among the multiple consumers. See, just imagine a situation where on a single CPU, there are multiple computers are there which are going to access a particular resources. So at the time the queue works, the first in first out manner. If you know about the OS concept of first in first out, you will get a better idea about it, how the queue works. The next is sorting out the data. Yes, queue is used to sort the data. Next is buffer on MP3 player. If you ever even see the MP3 player, okay, where your song playlist is there, the first song will be played first, then the next, then the next, then the next. Such like this is an example of queue. Okay, your computer system must be often provide the holding area. I have already talked about such example of the resources. Your PC must have so many resources simultaneously processing. Okay, at the time the CPU processing power must be there of the queue or the process which has the highest priority. Fine. So queue is used in our day-to-day life as well as in our computer, mobile applications and everywhere. Okay, you just have to find out some more examples of the application of queue. So that's it to all about the queue chapter. We have seen single queue insertion, deletion, circular queue insertion, deletion, DQ insertion, deletion at front end, DQ insertion, deletion at rear end, priority queue and application of queue. That's it all about the queue. So if you have any doubt, then please feel free to ask me. Thank you so much.